Hi, welcome to Unlock Layout and Design YouTube channel. Today we are going to discuss an important concept called deep Nwell. So where a deep Nwell is used and what is the need for it. Before understanding what is deep Nwell, first let's try and understand what is the Nmos transistor bulk connected to. Okay, now I have two transistors here, M1 and M2. Both of them are NMOS transistors. Okay, so this one is the drain of this M1. This one is the source of this M1. This is the drain of M2. This is the source of M2. This one is the bulk of M1, and this one is the bulk of M2. Okay, so when you have a P plus here, and this entire thing is a P minus substrate. This entire thing is a P minus substrate. This is connected to the substrate, and this is also connected to the substrate. Okay, so this and this are connected through the substrate. Basically, they are all connected to the same substrate. And we know the bulk of NMOS transistor will connect it to the lowest potential, which is ground. So if I connect M1 transistor bulk to ground, by default, all other M1, M2, M3, M4, how many ever NMOS transistors are there, their bulks are also connected because this is connected to ground here. Now this is also connected to ground. Whether you explicitly connect here to ground or not, basically it is connected to ground. So the bulk of normal NMOS transistor is not isolated. This is very important. If you connect one bulk to ground, all NMOS transistors are connected to bulk is connected to ground. Understand? Only maybe here if I connect it to ground, then this bulk is connected to ground by lesser resistance, and if I don't connect it here, then this is also connected to ground but with some substrate resistance. That's all. Okay, now let's try and analyze a cascode amplifier like this, wherein I have M1 and M2, which is a cascode amplifier. This one is a cascode amplifier. M2 is the cascode device, M1 is the base device. So here we have in this diagram M1 and M2. When I connect M1 bulk, where is it connected here? M1 bulk is connected to ground. Okay, so here M1 bulk is connected to ground. I will call this M1 and I will call this M2. M1 bulk is connected to ground, and we know that by default even this is connected to bulk. But here source and bulk, both of them are at ground. But here this source is not at ground, say it is at 0.2 volt, but this bulk is at 0 volt. So whenever I have a potential difference like this, see, this is the cascode amplifier. Say assume this is 0.2 volt. This one is connected to ground. Source and bulk, both of them are at ground. But here source is at ground, but bulk is at ground, but source is not at ground, say around 0.2 volt. I have something known as VSB. This is source and this is bulk. V source bulk. Okay. Source bulk of 0.2 volt. Then what happens is, suppose for this NMOS transistor, the VTH will increase. For this transistor, say VTH is 0.6 volt. For this transistor, VTH will become say around 0.65 volt. VTH will increase, which is a disadvantage. So this effect is called as body effect. Now if I have to eliminate this body effect, I need a separate bulb for each NMOS transistor. So similar thing we will see even in this diff pair. See, here I have a diff pair. This one will have like a VTH say 0.6. These two transistors will have VTH little higher because this bulk is also connected to ground. They will have like 0.65 volt. Here I cannot connect this locally as explained here in this one I showed you, right? M1, M2. Whenever transistors are connected, any one of them is connected to bulk. All the bulks are connected to ground. All bulk, if any one of the bulk is connected to ground, all bulks are connected to ground in NMOS transistor. Now we'll try to understand how a PMOS transistor works. Okay, so this is the bulk of PMOS transistor B1 and B2. Suppose I have M2 and this is M1. Two transistors are there. They have bulks B1 and B2. Now in this case, is this bulk and this bulk shorted, or this Nwell? This bulk is connected to Nwell. This bulk is connected to this Nwell. Are these two Nwells shorted? So are they shorted? No, it is not shorted. This bulk and this bulk, they are not shorted. So this bulk, this Nwell and this Nwell, they are not shorted. So they can be two separate Nwells. So this bulk generally PMOS transistor, I will connect it to VDD. Suppose say VDD is 1.8 volt. I connect this bulk to 1.8 volt, and this is not automatically connected to 1.8 volt. I can connect it to any voltage. Say I will connect it to 1.6 volt. I can use, because these bulbs are isolated, because each one is in a separate Nwell. Both of them are in separate. Each PMOS transistor is in a separate Nwell. That's why the grounds are isolated. Whereas Nmos transistor, all bulks are shorted. Are shorted to ground. Now we will try and analyze a PMOS cascode transistor. Okay, cascode amplifier. Now this is M1 and this is M2. Now can I connect this? This one is connected to VDD. This bulk is connected to VDD. Can I connect this locally? Yes, I can do it, because here each source and bulk can be connected locally. So definitely I can do it, because each one is in a separate Nwell. This Nwell is different and this Nwell is different. Similarly, I can also have these two bulbs. I can connect it locally. So it is connected locally. This source and bulk is connected. This source bulk is connected. So definitely I can connect. There is no body effect here. It is not there in PMOS transistor. Okay, now we'll understand what is a deep Nwell. Okay, so now if I have a Nmos transistor M1 like this, so the bulk is connected to ground. If I want one more Nmos transistor whose bulk I want to connect to some other voltage other than ground, then what I do is, this is the P substrate. So what I do is, first I will put a deep Nwell. So this one what you see here is the deep Nwell. I will do a trench. See here also you can see the same thing. This is called a deep Nwell. Here I am going to trench deep this N plus or Nwell region. I will put two Nwells, deep trench, and then I will connect it using a deep Nwell. So now what happens? This P substrate inside this, right? This one, this P well. After that I will do a P well, and this P well is now isolated. Okay, so this P well I can connect it to some different voltage, say 0.2 volt or 0.3 volt, whatever voltage I want. Suppose I have two transistors like this. This one is M1 and this one is M2. This source and bulk I can connect here. So now this is M2 and this is M1. So here source and bulk are connected to ground. Here source and bulk are connected, and they are connected to the drain of this guy. Okay, M1 drain, and this voltage is this terminal. It can be like 0.2 volt. There is no problem, because I have the isolated. So I have this isolated. I have this isolated. This one is isolated P substrate. This one is the common P substrate. This one is the isolated. So I can do it. So this is the same deep Nwell concept. So this one is the P minus substrate, and this portion inside here, the deep Nwell, it is the isolated P substrate. So what are the uses of deep Nwell? We understood the concept of deep Nwell. Basically, we want to isolate the bulk of Nmos transistor And why we want to isolate? Because we want to reduce something known as the body effect. What does this body effect do? This body effect will increase the threshold voltage, which in turn increases the W by L of the transistor. The area increases, and there are a lot of other parasitic capacitances that will increase. So we don't want the W by L to increase because of threshold voltage increase. So for that reason, we use isolated bulk. So other important use is in RF transistors. I do a noise isolation using deep Nwell. So I take all the RF transistors, and what I do is I'll put them in a deep Nwell. So this ground is now isolated from the other ground. So hence the noise in the other ground will not affect the noise in the RF transistors. So thanks for watching this video. If you like, please hit the like button, and then don't forget to share and subscribe our channel. Thank you.